reactant. And in case of product, the rectangular hydrocolor will be made like this because the concentration is increasing with time. Okay. Now we can move forward because I have done till here. I've only done till here, and now I'll be writing also. Now the next concept is rate of appearance or disappearance. Rate of appearance or disappearance. I have to do an assignment of galaxy as well of chemical kinetics. Let me write it in my tuition. In my time today. I have to do chemical kinetics. Latest assignment. I had to ask also one question to solve in the class, but I forgot about it. That was from the second last assignment of chemical kinetics. That was given by Alexi sir. When rate is being converted into product. Pen has finished. Okay, I'm working too much. And pen is getting finished again. See, I have this thing, polythene, in which I keep all my finished pens, and it's like this much till now. You can see? Yeah, you can see. It has finished. Like, it is filled with pens only. See? It is filled with pens only. See? See? It is filled with pens only. It is in this polythene because the chain is not closing. That is why it is in this bag. I keep all my finished pens in it because I like it. I like watching this. I finished this with pen. Oh, I'm studying too much. I should stop it. So this is the reason why I keep it. When I get demotivated, I feel no, I've completed this much pen. I'm studying. I'm not. It's not like that I'm not studying. It is that I'm studying. I'm studying main. Yeah. Oof. Oh no, I forgot to get a new blue pen. No, I have it in my pouch. See, it's filled. I can get it from here. Don't tell me I don't have it. I have it. Yeah, here it is. This is a blue pen. Yeah, I was writing when reactant gets converted into product, rate of disappearance is defined for reactants only. This rate because reactants are the one which gets disappeared. Product will get formed. So this is the thing. So we can write rate of disappearance as it is defined for reactants only. It is defined for reactants only. In which R average is minus delta CR by delta T. Sorry for that. Excuse me for that. R average in case of reactant will be minus delta CR by delta T. So since concentration is decreasing with time. Concentration is decreasing. But rate can't be negative. Rate can't be negative. Negative sign indicates that concentration of reactant decreases with time. Indicates that concentration of reactant decreases with time. Rate of appearance will be, it is defined, rate of appearance is always defined for product only. Now in this case, since it is rate of appearance, it will be positive. Our average will be final minus initial. R instantaneous will be minus dCr by dt. Or it will be dCp by dt. If it is given a question, if we have given a question in which A plus B is getting converted into C, so we can write the rate as minus dA by dt equals to minus dB by dt equals to plus dC by dt. See, this is how I'm making the notes. The thing which are getting repeated, I don't highlight it again. I just highlight it the first time, and this is whenever there is a formula or something like that, I write it with black pen and outline it with a red pen. So this is how I'm making the things. So I just do all the graphs in a different color. So that is the thing. This is how I should make the notes because I have researched on it a lot and now I have got into a conclusion that this needs to be done like this. So I'm damn sure about it. If you start making your notes like this, you will definitely achieve success. एक रिएक्शन के लिए तीनों रेट सेम होगी क्योंकि रिएक्शन सेम है. ओके, फॉर रिएक्शन ऑल थ्री रेट्स विल बी सेम बिकॉज़ द रिएक्शन इज सेम मैन. एक रिएक्शन के लिए मेक श्योर, दिस इज अगेन वन पॉइंट दैट इज इंपॉर्टेंट, मेक श्योर यू आर यूजिंग हिंदी लैंग्वेज एज वेल इन योर नोट्स. द थिंग्स व्हिच आर डिफिकल्ट टू अंडरस्टैंड इन इंग्लिश यू शुड राइट इट इन हिंदी. सो दैट इज द थिंग एंड यू शुड नॉट फॉरगेट टू write the things which the sir or when you are taking any class from a madam or a sir he says in Hindi, do make sure to write it in your notebook. Okay, though he has written the same definition of it in English, if he speaks a sentence in Hindi then make sure you write it in your notes. एक रिएक्शन के तीनों के लिए तीनों रेट सेम होंगे क्योंकि reaction same है. Now if we have an important concept again, so I'm writing it with a black pen. I hope this is well. Yes, it's a black pen. N1A plus N2B gives N3C plus n4 d. So we can write the rate as minus 1 by n1 dA by dt equals to minus 1 by n2 dV by dt equals to minus 1 by n3 dC by dt equals minus 1 by n4 dV dt by dt. I got to know about the concept when I was doing my questions, so I will write that concept in my notebook, that in case of rate of disappearance and rate of appearance, we do not write the stoichiometric coefficient in the denominator. Make sure you are also doing that in your notes. In the denominator. Yeah. So that is again a question or concept. This is concept again. If you have given a question, a plus 2b gives 3c. This is a question in which my sir wanted to tell us a concept. If initial concentration of A is A, initial concentration of B is B, and initial concentration of C is 0, because the product is now not formed when t equals to 0, and when t equals to t, anytime t, a portion of A gets disappeared, and portion of B gets disappeared, that will be A B minus 2x and A minus 2x, and a portion of C will be formed, that is 3x, because the coefficient of C is 3 and the coefficient of B is 2 in the equation. So we can write the rate of disappearance of C as 3 dx by dt, and rate of appearance, this will be rate of appearance in case of C, because C is the product, which I have done wrong. And rate of disappearance of B will be B minus 2x minus B by t, that can be written as minus 2 dx by dt. And similarly, rate of disappearance of A will be A minus x minus A by t, that will be minus dx by dt. For writing the rate of reaction, this is again a very nice application of what we have studied till now. Rate of reaction will be 3 dx by dt by 3, that will be minus 2 dx by dt by 2, again it will be minus dx by dt. So we can write its generalized form as rate of disappearance is minus dx by dt, and rate of reaction will be, this is important, this implies rate of disappearance will be minus dx by dt, and rate of reaction will be minus 1 by n dx by dt. Since it is important, I am highlighting it with a red pen. Now we are going to talk about how to solve questions which needs pressure, which asks for pressure. So we will be using the gas law, that is P equals to nRT, ideal gas equation. This is the ideal gas equation, since it is not written here. For I think do like this. Take a notebook, fold it into 2 parts like this, and start doing like this. Now moving forward to this page. For a homogeneous gaseous equation, since it is gaseous, I am underlining the important concept with a red pen. The rate of reaction is defined in terms of pressure. We can write the ideal gas equation. If we have given a reaction, say N1A gaseous plus N2B gaseous gives N3C gaseous plus N4E gaseous, we can write the rate equation as minus 1 by N1 dA by dt equals minus 1 by N2 dB by dt equals 1 by N3 dC by dt equals 1 by N4 dd by dt. Rate can be written as, now on using the concept of ideal gas equation, that will be PV is equals to nRT. That can be written as P is equals to N by V RT. N by V will be concentration, that is molarity, equals to CRT, in which RT is fixed because R is the gas constant, that is 8.314 joule per Kelvin per mole. This is fixed, and this is also fixed because it will be at a particular temperature. Temperature is also fixed. So we can write P by RT as C, in which R is 8.314 joule per Kelvin per mole, or it can be written as 2 calorie per Kelvin per mole, or it can be written as 0.082. What is the unit of this? 0.02? Something is there. I forgot about it. I'll check it. Rate is 0.082 watt. Yeah. Joule can be converted into Pascal. I'll be checking it. I've written it. I'll check it. 0.082. What is the unit of this 0.082? What is the unit unit of gas constant when it is 0.082? So it can be written as rate will be equal to minus 1 by N1. We can write the concentration as P by RT. So this will be minus 1 by N1 divided by RT dPA by dt equals minus 1 by N2 RT into dPB by dt equals plus 1 by N3 RT into dPC by dt equals plus 1 by N4 RT into dpd by dt. So rate will nothing be, it will just be the, in the rate equation, we will write the pressure in the place of concentration. Rate will now be 1 minus 1 by n1 dpa by dt equals to minus 1 by n2 dpb by dt equals to 1 by n3 dpc by dt equals to 1 by n4 dpd by dt. This is important. I am highlighting it with a red pen. Make sure you are writing your notes, separately. You leave too much space. So that is what you have to do. It should be spacey, like airy. This is how you have to do. Because in case you are solving the questions, you get a new concept, so you can add it in your notes. That is why it should be full of spaces. Now I will bring my law of active masses. See, for starting a new concept, I have left this much space. Law of active mass. I write every heading in black pen, and it is very important to write your headings in your notes. It is important. Note it down. So, law of active mass states that, make sure you are not writing is and are in your notes, and you use as much precise words as you can. In case of reactant, you can write REAC and N in the superscript of react REAC. So it says that the rate of reaction you can use RXN as reaction is directly or directly proportional. You can use the proportionality sign, but I wrote directly, so I will be using directly proportional. You can write directly proportional to dPt, like how you do with respect to WRT. That is what it is. It says that the rate of reaction is directly proportional to product of concentration CON and N in the superscript. It says that the rate of reaction is directly proportional to the product of concentration of reactants raised to the power of this stoichiometric coefficient. So it is for an elementary reaction. Elementary reaction, yeah, we will study about it later onwards, since this is my teaching note, so I know about it, what is going to come next to this topic. I'll wait then. That is why. Yeah, it says that the rate of reaction is directly proportional to the product of concentration of reactants raised to the power of this stoichiometric coefficients. For example, let's take an example. N1A plus N2B gives a product. The rate in this case will be directly proportional to the concentration of A raised to the power of that stoichiometric coefficient of A into concentration of B raised to the power of the coefficient of B in the reaction, that is N2, and we can write rate as, by removing the proportionality, we get a constant, that is proportionality constant, that is named in this case rate constant in case of law of active masses. So rate will be K, A to the power N1 into B to the power N2, when A and B are the concentration of A and B respectively. Now I will be writing my rate law or rate expression topic. I'll leave some space. Rate law or rate expression. Make sure you are using a blank page for your notes, because it makes it easier to draw everything and write everything in it. So yeah. Make sure you use different colors for heading and for important things, but make sure you're not using too much friends, as if you're changing again and again. So make sure that. Rate law or rate expression is based on law of active mass only. If you have given an equation, N1A plus N2B gives N3C plus N4D, so we can write its rate as K, concentration of A to the power X into concentration of B to the power Y, in which rate is the rate law or rate expression, and K is the rate constant or specific rate of reaction, and X is the order of reaction with respect to A. That will not be calculated by seeing the, that will not be calculated theoretically by seeing the coefficient of reactant, that particular reactant in the reaction. That will not be done in case of writing the rate or rate expression. The order will be found by experimental techniques only. It cannot be evaluated theoretically, because it does not have to happen actually like that. So K is the specific rate of reaction, and X is the order of reaction with respect to A, and Y is the order of reaction with respect to, I'm writing the wording in case of with respect to B. Now next concept is specific rate. If we have given a rate law, that is rate equals K into A to the power X into B to the power Y. So we can write rate equals K if concentration of A equals concentration of B, that will be 1 molarity. So this is the, when concentration of A and B are 1 molarity, then the rate law's rate is K, that is specific rate, and then the rate constant is called specific rate constant. and that reaction when we take 1 mole of reactants, so that reaction is called specific rate law reaction, and this is called the specific rate. When the concentration of reactant becomes unity, then rate law is equal to rate constant and is called as specific rate. That rate constant is called specific rate. Now we are moving forward to types of reactions. That is divided into 2 categories. That is elementary reaction and complex reaction. Whenever we have such categorization into 2 or 3 or even more, then make sure you are writing that in a flowchart like this. So we will be studying the elementary reaction, complex reaction part, and in which elementary reaction are the reaction which can take place in a single step are called as elementary or single step reaction. We can call it elementary reaction or single step reaction. Reaction which takes place in a single step. Law of mass action is truly valid for elementary reaction. Okay. Law of mass action is truly valid for elementary reaction. Rate law of an elementary reaction can be written by using the short coefficients. Yeah. Rate law of an elementary reaction can be written by using their stoichiometric coefficient. For example, an elementary reaction. So by solving the question, I found out that there is given in the question that it is an elementary reaction. So sir said if it is not given in the question that it is an elementary reaction, then assume it to be a complex reaction, and when it is given, then it is of course an elementary reaction when it is given. I don't know if I should keep this here like this or here like this. I think it's much better because now my this thing is not that visible. Yeah, now it's fine. Now it's fine. Elementary reaction. Now I'm writing that concept here. That and whenever it is given in the question, then only use it. If it is not given in the question, then assume the reaction to be complex reaction. So make sure you are making your concept after you are done with your questions of that chapter after completing it in your class. So first read the questions, then make your notes. Answer. But by doing the questions, you get to know that what is important in the chapter and what is not important. While when you are making your notes just after your class, then you don't know which is the important concept, and therefore you cannot make the notes concise. You just write everything in the notes, just like everything. I'm not liking it, so I'm making it like this because I love it, because I love this portion of my head. I love this portion of my head, and not this that much, but it is also fun. Look how beautiful it is, like this and like this. If it is given in question, then only use it. Otherwise if question do not specify which reaction is this, then assume that reaction to be a complex reaction. For an elementary reaction, N1A plus N2B gives any product. Since you have to write the rate law or rate expression, so we will be concerned with only the reactants, not the products. So that's why while giving the example, sir has just written the word product in the product. He has not specified it because we don't need it in rate law or rate expression. So that thing. So we can write rate as K, A, N1, N2B, N2. I'm specifying it again here that it is for elementary reaction only because it is important. Now there is a note point for an elementary reaction. Law of mass action and rate law both are equally. We can write it like this. Law of mass action and rate law both are equal. I want to go to the toilet. Just a second. I have decided right now that I will not go to market to get my watch. I will study and complete the offline things, and then I will go to there tomorrow because tomorrow I leave for tuition. So I will take my watch then. I will not prioritize getting watch. I will prioritize my studies because so much things are left. This is what you should also, and this is what toppers do. So I'm copying them. I'm not a topper. That is why. So we're gonna be starting complex reactions. I left this till elementary reactions. So I'm moving forward to complex reactions. That's why I'll leave some space if I get anything new about elementary reactions. Complex reactions are not called anything else, like how elementary reactions are called single step reactions. So this is not called multiple step reactions. Complex reactions are the reactions which can be completed in more than one step. Easy peasy. If not given in question, then reaction is complex. In a complex reaction, each step is an elementary reaction. Each step, yeah, just the steps of that is an elementary reaction. Oh, my back is paining, so I need to sit straight. And when I sit straight, my arm is starting. Like it literally, scares me when it does like that. I did not have any other notification sound in my notebook. That is why this one. Each one is like natured. But I changed it. But I don't know why it is not changing. In a complex reaction, each step is an elementary reaction. For example, we have given an equation 2NO2 plus Br2 gives 2NOBr. So we can write the rate as, the rate will be KNO to the power x and Br2 to the power y. Now the step 1 in this reaction is NO plus Br2 gives K1 in presence of, in rate K1, that is the rate constant, and the rate constant is K1. And Br2 will be formed, and this is a fast reaction, and the slow reaction is the rate determining step. Step 2 will be NO Br2 plus NO gives K2. 2NOBr is a slow reaction, and the rate in this case will be, there will be a separate rate law for each elementary reaction, and it will be K1 into NO into Br2 to the power 1 and Br2 to the power 1, and in this case of K2, the rate will be K2 NOBr2 into NO. This will be the rate determining step. I've done 2 pages. No, even more than that. Yeah, I've done 4 pages till now. And it's been, oh my god, it is not visible. Oh, I stopped it when I went to the washroom, right? So it's 6 minutes after I came from the washroom. So actually, it is more than that. I have to take a blank sheet because this sheet is completed. See, I've got too much of it. It is cheaper than a notebook which contains blank pages, like lots and lots of blank pages. Because in this is of 50 rupees and sheets will be 20. And this is the notebook in which all are blank pages. So it is of rupees 80, in which we will be given 192 pages. It is cheaper, copy is cheaper. But its quality is not good. Its quality is not good, it's very thin. And it's a bit good quality. And we should use a good quality page for our notes because we have to keep those notes for a long time, and especially the JEE aspirants, because they have to keep the notes for a long time. They have to make notes of 11th and 12th and give the JEE in after 12, and if they drop, they have 1 year. So that is why you need a good paper quality of notes. This is what I do to separate. To fold the page, I first join it from the ends and then make it, and then I scale it from between. I did not scale it before because it is the nice thing to do. I did not, scale it from a scale. I just fold it first and then I make the lines so that it's easier. So if you make the lines before, then you will be doing from this 3 steps. And if you do it like this, you know the line is here. It will not take much time. So this is the thing. This is a thing in which you can make your notes faster. Yeah, there's a note. It is a complex reaction, so I think I should complete it here only. Here itself. Origin theory. Origin theory is deleted. Those are not it. That's good. We have the note point. In a complex reaction, slow step is the rate determining step. Oh, I wrote it before. I still have to do it again. Slow step is rate determining step. Now I think I should first write the origin theory in this. Origin theory is important and easy as well. Origin theory. जब तक रिएक्टिंग स्पीशीज कोलाइड नहीं होगी तब तक प्रोडक्ट नहीं बनेगा. This is the collision theory. I am just writing it in Hindi. Whenever you have given Hindi and English, prefer Hindi in notes because it's more easy to grab in your mind. And when you see a Hindi word, you concentrate in it more. That is why you do not get bored while reading the notes. So make sure you're filling it with Hindi sentences. Does not fill it everywhere in Hindi. You want me to your home notes in English? It's an English medium school. That is why. Molecularity. It is a theoretical concept. Theoretical. Okay. It is a theoretical concept. Molecularity is theoretical. That means we can write the molecularity by seeing the reaction itself. It's easy. We did not calculate it from experimentally. Molecularity is a theoretical concept. Or molecularity balance reaction in integers. Now the definition is the number of, I don't want to write the but I wrote it somehow. The number of reacting species which collide together form product is called as molecularity. Okay. The number of reacting species which collide together to form product. Now we have given an example in which we have given a reactant CaCO3 which gives CaO plus CO2. Molecularity will be 1 since it is a unimolecular reaction. And in case of H2 plus I2 gives 2HI, molecularity will be 2. This implies it is a bimolecular reaction. 2HI gives H2 plus I2 is also having a molecularity equal to 2. That means it is a bimolecular reaction. Even if we have a coefficient 2 in the reactant side, then it is a bimolecular reaction. And if we are having 2 molecules in the reactant side, then also it is a bimolecular reaction. We have given some important points to be noted. That is, molecularity of reaction cannot be 0, negative, fraction, or infinite. Okay. Molecularity of reaction. I should have written only molecularity. Molecularity can't be 0, but I wrote it. Can't be 0, negative. We can write negative as minus VE. And fraction, I have to write FRDC and N in superscript. Or infinite. I can write infinite as this. Okay, understand? 8 in the horizontal position. This is infinite. If you are a small student and you don't know what is infinity. Molecularity of reaction greater than 3 is rarely, rarely observed. This is an important concept. Questions are asked in JP from this. And many both questions are also solved like this. Not exactly like this, but there's a trick. You have to only just take the, if you have given to check the order of reaction, then you can skip the free of order reaction because that's very rare. So this is the thing. Because what is the reason? Because the reason of this, molecularity जितनी ज़्यादा होगी, कोलाइड होने की टेंडेंसी उतनी कम होगी. टेंडेंसी उतनी कम होगी. जितने ज़्यादा मॉलिक्यूल्स होंगे उतना कम होगा कोलाइड होने की टेंडेंसी. Because the tendency of 4 molecules to collide together and form product is very less. Because the tendency of 4 molecules to collide together is very less. That is, we do not have molecularity greater than 3. And 2 plus 3H2 gives 2NH3. We have given an example of it. But still, there are some reactions which are having molecularity greater than 3. Those are N2 plus 3H2 gives 2NH3. K2Cr2O7 plus 2K2C2O4 plus 14 HCl gives KCl plus CrCl3 plus CO2 plus 7H2. For complex reaction, molecularity of each step has its own, and overall all molecularity does not mean anything. For complex reaction, molecularity of each step has its own, and overall all molecularity of reaction does not mean anything. Okay. English was wrong in this. Now it's correct. For a complex reaction, each step has its own molecularity, and overall molecularity of a reaction does not mean anything. I think it is important, so I'm writing it to the black pen. For a complex reaction, each step has its own molecularity, and hence, no, I should not write hence, and overall molecularity of a reaction is not known. Of reaction does not mean anything. How is my anything? You're nice, huh? I know it. Come a baby. Jana matlab hi mare hum milenge na kabhi to bas marne no bano ke chhod ke jaao bas. 2NO plus Br2 gives 2NO Br. If there's a reaction, NO Br2 plus NO gives NO Br. So its molecularity by seeing the reaction will not be calculated because it is a complex reaction and we have two steps in it. That is 2NO plus Br2 gives 2NO Br and NO plus Br2 gives NO Br2. So in the first step, the molecularity is 3. In the second step, the molecularity is 2. And overall molecularity of the reaction cannot be determined by seeing the reaction.